All right, let's get started. Good morning, everybody, and welcome to our second Orange Cyberdefense OT security webinar for this year. My name is Edwin Rombeek, and I'm responsible for the new business team within Orange Cyberdefense. And together with my colleague Peter van der Voort, our solution architect for OT, we have a focus on this area. So what you can expect during this webinar on OT security, because in general, cybersecurity in the OT domain is right now not a very high level. So just some small adjustments can already make the difference. So Peter will talk and will walk you through 5 basic security measures for the OT domain that you can do yourself. So if you have questions during the webinar, you can ask them on the GoToWebinar sidebar, and we will answer them at the end of the presentation. This session will also be recorded. So Peter, back to you.
Thank you, Edwin. So let me briefly introduce myself. I'm Peter van der Voort, and at Orange Cyberdefense, I'm a solution architect specifically for the OT domain. And this means that I have quite a technical background. And what I do is helping organizations actually to move forward if they want to adopt Industry 4.0. And I realize that Industry 4.0 is a bit of a buzzword. It's an umbrella term, but in many cases, it's about increasing the efficiency of operational processes or optimizing production or move data to the cloud for analyzing or even building digital twins. In any case, everything that can be captured by the word Industry 4.0, I help organizations to do this in a cyber secure way, mainly by providing advice about technology or about processes or even by implementing technical solutions. Okay, in any case, so in the next half an hour or so, I'm going to say something about measures that you can take and that are quite easy to do as well. And that will actually help you to increase the level of cyber security of your industrial network. And the title of this webinar says 5 measures, but actually I'm going to give a few more. But they're based on 3 categories, if you like, that you can see here. And they're in no particular order. I would say they're all just as important. And the first one is about segmentation. And I'm going to talk a bit about best practices, really, in this respect. And some of you may be familiar with this already, but it's an important subject, and I'm going to elaborate on some specifics. And the next category is monitoring, and there is actually quite a lot to tell there. In this category alone, I think I will already provide like 5 tips, and these are based on logging. They're based on a decoy called a Honeypot, and on network traffic analysis. And again, this is all about things that you can do yourself at little or no cost. So no expensive commercial solutions involved here. And the last category is about governance, or rather processes and procedures, because I think it's quite impossible to have efficient cybersecurity if you don't have processes surrounding the technology. So I will dive into that a bit as well. And we'll conclude this session with just a little bit of information about Orange Cyberdefense. I hope you allow me to do so, but I promise to keep that very short. It's just that if you like sessions like this, there's a lot more to come next month, and I want to share that with you. And at the very end, we will go on to the Q&A. So let's get started like this. Okay, first, segment the network. You know, in IT networks, it's quite common practice nowadays. Although 10 or 15 years ago, I quite often had to deal with networks that weren't segmented at all. All devices were really in one big happy VLAN, and this was most of the times just a default VLAN, VLAN 1. And from one perspective, it makes sense to build a network like that, you know, especially in the early days of networking. Because when a new switch was taken out of the box and switched on, all ports were per default in VLAN 1 and per default enabled. So by connecting devices to the switch, they could all just communicate, and there was no need whatsoever to put a difficult configuration onto the switch. I mean, why would you if it just works out of the box, right? And it actually worked like this for quite some time, but then networks became too big and too many devices in the same VLAN. And these devices are all sending broadcast traffic, and that resulted in performance degradation of all devices on the network. But also, if one device got compromised or got infected with malware, that malware could spread easily across the entire VLAN without anything stopping it. So these are already two reasons for segmenting a network. And when looking at today's industrial networks, I sometimes see that the OT domain, so to say, is a single VLAN or sometimes 2 or 3 VLANs on the IT network. So the industrial network is sharing hardware, sharing switches with the IT domain. And in itself, this may work, especially in smaller environments or in environments where there's no budget for separate hardware. But an IT switch is in general managed by the IT department. And in the IT domain, there are generally much more changes than in the IT domain or the OT domain. And changes basically means risk. So therefore, the better way to shape this is to physically separate the IT domain and the OT domain. Just put it on separate hardware if you get the chance. With that being said, let's have a look at what's on the screen here. This is what we call the Purdue model for industrial control systems. And this is a sort of reference architecture, a best practice method to segment the industrial network itself, but also to separate the OT domain from the IT domain. And this model provides different levels, which could be seen as segments, although that's not entirely true, and I will get back to that in a bit. But let's first have a look at the different levels and the equipment that is typically found on it. At the bottom, level 0, this is the level where equipment is like motors or fans or conveyor belts, things like that. And above that, level 1, there's equipment to control level 0, using, for example, PLCs and RTUs. And level 2 houses supervisory control and visualization systems, in other words, SCADA systems. And on level 3, there will typically be equipment like HMIs, historian database, or a MES system. And then let's jump to level 4 and above. And this is the enterprise IT domain, office automation and things like that. Now, the reason that I skipped level 3.5 for a moment is that in the old days, as in before 1985 or something like that, there wasn't really a thing like an enterprise IT network, let alone the internet. You know, if you know that ARPANET, I'm not sure if you have ever heard about it, but they started using TCP/IP as communication protocol in 1983. And this was really the basis for communication and for the internet as we know it today. But now that we do have internet and we do have enterprise IT, under the influence of Industry 4.0, and we are increasingly start to connect the OT domain to the IT domain. And that's where level 3.5 comes in, because if you want to connect a high secure domain like the industrial network to a less secure domain like the internet, well, best practices dictate that you need a demilitarized zone. And that's what level 3.5 provides. So here you will find devices that can be accessed from both the OT domain and the IT domain. But communication between OT and IT should always go indirectly. And this basically is the first thing that you can do yourself to increase the cybersecurity level of the industrial network. I'm sure most organizations have a firewall, right? So if you put the industrial network on a separate physical interface on that firewall, and then at least there is a separation between IT and OT. And even if you put a statement on the firewall to allow all traffic, but at least monitor it, you will have a gain, really. Now, obviously, by putting the industrial network on an interface doesn't give you a DMZ. But if you have one more additional interface available, that could be used as DMZ. So that would then be set up as can be seen at the left side of this picture, a firewall with 3 legs. And as you can see on the screen at the right side, I've put multiple firewalls, and these firewalls are all in between the different levels. And that would make sense, right? Because why would a PLC on level 1 have to communicate with, for example, something in the IT domain, or the other way around for that matter? And I do know that sometimes there can be an HMI in the IT domain or something like that, but that just means that it should be moved down to level 3. But placing firewalls between each level would be a good idea, actually. And if not for blocking traffic, then at least for monitoring it. And I think you get a picture of what I'm trying to say here, right? So create different levels, group specific types of devices per level, and come up with a dedicated security policy for that level. That can be based on the actual vulnerability of devices on that level. This also means, by the way, that the different levels are using different IP subnets. So no longer everything in one VLAN and in one subnet. There must be different subnets so that the traffic can be run through a firewall. And there's one more thing to say here about what I mentioned before, that a segment and a level is not necessarily the same. And what you see here is that you can actually segment the levels. And a good reason to do so is that you can create a segment, for example, per production line or per specific control system. And in that way, when something happens to one control system, it doesn't per se impact another control system. So this will basically increase the availability of the production process. And then you could even place firewalls on one level between these segments. Even if there's only one subnet on that level, you could configure the firewall as a layer 2 firewall and have these segments separated from each other. And fair enough, it may be a bridge too far because the last thing you need is latency on these levels, but just know that it is a possibility. Anyway, the takeaway here is that you can segment the network, and if you already have a firewall, it will just cost you some time and effort, and that's it basically. The next one is monitoring. And let's start with Syslog. I'm not sure if everyone is familiar with it, but Syslog is a common standard for logging of messages. And this protocol has been in use for decades on network devices like servers, routers, switches, firewalls, and probably any other network device you can think of. Now, looking at devices like PLCs and RTUs, these also sometimes support Syslog, but unfortunately it's not as straightforward as with IT devices, where it's just a matter of switching it on basically. But Syslog provides information about alerts or error conditions or warnings or information about a specific status of something, things like that. But Syslog management is key, because handling all the data that comes in through Syslog can be a real challenge, basically due to the enormous number of messages that can potentially come in. So what you would need is a good Syslog server. And there are a few out there, to be honest, both paid and freeware. And looking at the freeware solutions, I would be inclined to mention that the Kiwi Syslog server is a good one. But since this server is offered by SolarWinds, I'm not sure if this is a really good choice at this moment. Reason for saying that, I don't know if you're up to speed with it, but SolarWinds suffered a hack late last year and is still trying to recover from that. And I honestly don't know if that hack affected their Syslog solution, but still it feels a bit awkward to recommend it at this point of time. But if you do a Google search on freeware Syslog software, you'll find a lot of alternatives. And again, Kiwi is a good one as well. And Syslog will show messages like who is trying to log into devices and who succeeded and who failed, like shown here on the screen. But it will provide much more information. And actually, we could do a webinar on Syslog alone. But for now, just know that Syslog is worth looking into. And by capturing messages like this, it will increase the cybersecurity level. And then there's a honeypot. And a honeypot is a system that pretends to be a production system of some sort, but that is deliberately vulnerable to attacks. And this means that when attackers see this device, they will notice the vulnerabilities and they will continue their hacking efforts with this device. Now, obviously, you could just let these attackers do their thing and leave them alone. But in general, it is very closely monitored what these hackers are doing. And in this way, you will actually learn about their methods. And you can use that knowledge to protect your network or servers. And there's also another way in which you can use this. For example, you could set up a server that no one should ever communicate with. So all traffic you would see on a device like this is should be some broadcast traffic. And that means that if there is any other traffic, it will be suspicious. So if a hacker is scanning the network or some sort of malware is trying to increase its footprint, you will most likely see traffic on this honeypot device. Just set up some automatic alert so that you actually got notified of malicious activity. And there are different types of honeypots, both commercially and freeware. And a honeypot can be specific for SSH or HTTP or for a database or for email. But nowadays there are even honeypot projects specifically targeted at industrial control systems. And if you would like to do a bit of reading on that, I can recommend the URL that I've showed here on the screen. And I don't have any affiliation with this site or with the writers of this document, but it's a research paper and I got some valuable insights from it. So perhaps it's insightful for you as well. With that in mind, a honeypot is usually quite easy to set up. And obviously it kind of depends on the system you choose, but still, it's mostly aiming to be as easy as possible. Having that said, if your aim is just to detect malicious activity, and there is another method which is even easier. Just deploy a server, which can be very small or even a virtual server, and deploy a listener on the interface which is connected to the network. And this listener can be as easy as TCP dump on a Linux system or even Windows, and then it's called WinDump. And for those who don't know, TCP dump or WinDump are just very small applications that have only one task, really: listen to network traffic. That's it. And then you can set some rules based on the traffic that is received. And one of these rules obviously can be to alert or to send an email or whatever. You could even filter on what to listen for. And that makes it even more versatile because then you wouldn't even have to deploy a separate server. You could just use an existing server. And then in TCP dump or WinDump, create a whitelist of all types of traffic that you would expect to see, and then alert on any other traffic. So for example, suppose there's a web server in a network segment that you want to protect. Now on this web server, install TCP dump or WinDump and create a rule saying that any HTTP or HTTPS traffic directed at this server is allowed. Then create another rule saying to alert on any traffic but HTTP or HTTPS. So now when there's any kind of malware trying to increase its footprint in the network by scanning an IP range, as soon as it hits the prepared server, you will get notified. Now, this is really a very efficient solution to detect malicious behavior in the network. Any applications I've mentioned, TCP dump and WinDump, these are open source applications, so you can just go ahead and download them. And I'll bet that you will be up and running with a detection mechanism like this within really 1 or 2 hours. So there you go, an efficient intrusion system, really right at your fingertips. It's very easy to set up yourself. Okay, so let's move on to the next thing that is very easy, but above all, very, very useful, which you can do yourself. And I'm talking about network traffic analysis with Wireshark. And to start with a brief introduction, Wireshark is perhaps the world's most used network protocol analyzer, and it lets you see what's happening on the network at really a microscopic level, in the sense that it can do deep packet inspection, and you will be able to see each and every bit of a packet. But of course, just seeing a packet doesn't really give you much information, but Wireshark is able to actually interpret the data up to a certain level, and it will be able to recognize like hundreds of protocols, including industrial protocols. So why would Wireshark be useful? Well, there are a few things actually, starting with the ability to view which protocols are on the network. And this may not be a big thing, but it's always good to know what's going on in the network. So if you see protocols that you wouldn't expect, then there's reason to further investigate. And even if it's not about protocols, if you just see specific TCP or UDP ports being scanned, that's also a sign that something isn't right. So this simple mechanism of seeing protocols and port scans will immediately give an indication of malicious behavior. Next thing you will be able to find out with Wireshark is to get an inventory of devices on the network. Because if you see each IP address that communicates, you will be able to establish a real-time inventory of communicating devices. And that can really be worth a lot, because in many cases, it's not clear what devices are really connected to the network. And that in itself poses a security issue, because you cannot protect what you can't see or what you don't know is there. So visibility in this respect is going to raise the level of cybersecurity tremendously. And there's even another advantage of this, because what if a device like a PLC fails, but you didn't know it was there? Well, until it failed, obviously. But would you have a maintenance contract for it? Well, probably not if you didn't know it existed. On the other hand, do you maybe have maintenance contracts for devices that are no longer on the network? In other words, is money being spent on devices that are no longer in service? And note that Wireshark, by the way, is a passive solution. It passively listens to network traffic, and it may be tempting to use an active solution like Nmap to actively discover OT assets, but you'll have to be very careful with older equipment, as that usually don't really like scans, and they may fall over or reboot or do other unexpected things. So these are all good reasons to get an inventory of the assets on the network, and it can all be done with a simple free tool like Wireshark. There's one more thing that I'd like to mention that you can do with Wireshark, which will really tremendously increase the security of your network. By just listening to network traffic, you will be able to see which device is communicating with which device. And it seems like an open door, but the thing is that you will also see malware trying to communicate with a command and control server, for example. And you will also be able to see that an engineering workstation, which you thought was only connected to the OT network, now communicates with the internet, for example. So looking at traffic flows, you will be able to very quickly identify illegal communication and illegal behavior. And if you do see that engineering workstation accessing the internet, or you see any other unexpected traffic flows, then at least you know and you can take appropriate measures. But if you don't know, you will most likely find out the hard way. With all these great capabilities of Wireshark in mind, please do realize that it can still not be compared with commercially available tools that sniff the network and find software versions and match these against the vulnerability database, or provide an inventory overview of actual device types, makes and models, and automatically alert on illegal traffic flows or deviations from a baseline. And the same really goes for TCP dump or win dump, although these are great tools that can quickly raise the security level of your industrial network. It will still require some manual effort. But if you're up to that, go ahead and take advantage of it. The last thing I would like to mention that you can do to increase the cybersecurity level is around governance. And I already mentioned this in the introduction. I don't think that you can get good cybersecurity with technology alone. You need processes and procedures. And this is a subject again where there's really a lot to tell. But for now, I'm going to make it quite brief. And what I want to do here is just mention a few processes to consider for implementation, or at least for review. And the first I'd like to mention is around remote access, especially given what happened over the last year, where more and more people are working from home. But it also goes for suppliers and vendors who need remote access for maintenance activities. So make sure that you have a process in place that deals with authorization of such remote connections. And the next one is incident management. If an incident happens from a cybersecurity perspective, it is imperative that everybody knows what to do and how to handle the incident. So, do you have an incident response procedure? And does it define specific roles and responsibilities, perhaps even based on different types of cybersecurity incidents? Incident response also includes awareness in the sense that people must be able to recognize a cybersecurity incident, and they must know how to report on it. And following the incident response procedure or plan, it is important to have a contingency plan, because if you do get hit by malware or someone does hack into the industrial network, there must also be a plan of what to do when everything goes wrong. You know, a contingency plan or emergency plan is going to help you get through such a situation. And the last one I want to mention is the risk assessment procedure. Is there a procedure to actually assess the threats, the vulnerabilities, and the possible consequences? You need to know, because that will help you with incident response as well. Because there is a difference if the consequence is just disclosure of information or the consequence is destruction of a system. And these are just a few that I wanted to mention. Obviously, there can be many more procedures like change management or about maintenance or things like that. But the point here is that governance is one of the things that can quite easily be implemented, and it will immediately raise the level of cybersecurity. To conclude on this subject, if you're going to set up policies and procedures, don't forget to communicate to your workforce, because a process that nobody is aware of is not going to help anyone either. With that, we're going to wrap up. I really hope that you've learned something new or gained some insight that you can use in your situation or at your company. And to close this off, please allow me 30 seconds for a shameless pitch about Orange Cyberdefense, because over the past 12 years, we are already known to be a leader when it comes to cybersecurity in the IT domain. And now by utilizing this knowledge and knowing that a lot of attacks on OT are based on IT cyber attacks, and we are very well positioned to help organizations to secure industrial control systems from cyber threats. And we don't provide cybersecurity for the sake of cybersecurity, but by doing this, we actually help organizations to move forward on their goals, which nowadays are often summarized as Industry 4.0, as I mentioned before, and often involves optimizing operations or working more efficient, saving costs and things like that. And to help organizations, we have built a demo center in which we can reproduce parts of real industrial control systems. And we can test software upgrades or patches. And we can provide training. We can actually reproduce attacks to learn how to protect against them. And there are many more things we can do to support you in this domain. So if you have additional questions or run into issues, just know that we will be able to support. With that, we've come to the end of this webinar, but on March 10, we organize Orange Cyberdefense Live 2021, which was previously known as the SecureLink Bootcamp, which was a physical event. But as you can imagine, that isn't going to work at the moment. So we made it a virtual event. And this isn't just about OT cybersecurity, but also about cloud security, ethical hacking, security awareness, and much, much more. You can still register via the link shown. It's going to be a very interesting event, so make sure to register. So at this point in time, Laura, can I ask you, are there any questions? Were there any questions that came in?
Yes, Peter, we actually had a few questions. First one is what your experience is with vendors in OT that dictate that you cannot use IDS, IPS, or antivirus, for example, and that if you would use those kind of projects, that they will no longer provide support.
I'm not sure I get the question really about vendors. If we use IDS vendors, is that the question?
The question is from Dave. Maybe Dave can repeat the question. Let's see.
Can you otherwise repeat the question?
It's what your experience is with vendors in the OT branch that dictate that you cannot use IDS,
okay, now I get
IPS, or antivirus products.
Yes. Okay. So I missed that first part. Okay. So yes, there is a thing. So for example, if you want to use some detection mechanism, for example, on an OT system, that vendor will say, okay, then you don't have any warranty or any support or whatsoever. Because you can imagine that if, for example, an HMI run on Windows XP and you start patching it yourself, the vendor will say, well, you know, that's fine, but if anything goes wrong now with this HMI, you're on your own because you changed my system, for example. So that's why it is important that if you use an IDS system, and Mark, I'm really using IDS, intrusion detection, and not intrusion prevention. So if you use an IDS, it is imperative that it is a passive solution. So it must just listen on the network, and it must not interact with any OT-related devices. And the vendor can never dictate that you cannot just listen to network traffic, right? So you're just responding on what you see on the network, and you're not interfering with any OT device. That's it. Any other questions?
Yeah, we actually have a few if you have the time.
Sure.
We had another question about what about implementing PAM products between segments or levels? Do you see it as a best practice?
Privileged access management implementing in between the levels. I'm not sure if that should be done in between the levels. What I do believe, though, is that you should carefully look at how you organize access to your OT assets. For example, if you have people, employees working from home, or if you have vendors working from remote. So what happens if they get access to your OT asset? You need to share a username and password, right? Okay, but what if those people leave the company? So they are familiar with the passwords. So what are you going to do? Change all passwords in the OT domain? I kind of doubt that that is going to happen. So what I think is that you should deploy a solution to access the OT domain where a remote worker does not need to know the password. So from that sense, I think there should be a solid, well, PAM or IAM system that takes care of authentication and authorization. And I think that by deploying such a system, well, that's a best practice in itself. So I'm not really sure about implementing PAM in between the levels, but I do agree that you should have a good system for remote access. And if you have such a system, then what you could also use this for is that if, for example, a maintenance engineer of a vendor is visiting a factory, for example, and what he usually does is he takes his own laptop and plugs it into the industrial network. But you have no idea where that laptop has been or what is on it in the sense of malware. And usually when he plugs it into the network, he has access to everything on that network. So I think that the better solution would be to give such a maintenance engineer access to the public Wi-Fi in your company, have him access the internet, and via the internet use the remote access solution, and then have him go through the same system that I just mentioned. So you can have him authenticating himself, for example, against your local Active Directory or whatever. But then every access to OT assets should be taken care of by the system without the need for this engineer to know the passwords. Yes?
All right,
Next
thanks. The next one is, how do you see modern developments like containerization and cloud-connected IoT for telemetry data work within the Purdue model and firewalling?
Okay, so it kind of depends on what is meant by telemetry data. If we are talking about industrial Internet of Things, that's something different than operational technology. So within the IoT, I do see that telemetry data is being sent, for example, to a cloud or to a data lake for big data analytics, or for building digital twins. Nowadays, I don't see many data directly from the OT domain being transferred to a cloud solution, for example. I think that people or companies, organizations are reluctant enough already to connect the OT domain to the IT domain. But I don't see them sending data to the cloud. But to be honest, I don't see any issue doing so. If you have a good separation between OT and IT, for example, using a unidirectional gateway, which you can use to, for example, copy databases like a historian database or whatever. And a unidirectional gateway makes sure that there's only one-way traffic possible. So there's physical no way back to the OT domain. Then you can safely publish data from OT in the IT domain or even in the cloud. And my expectation is that that will increase over the next few years, because if you can get data from the OT domain, you can use that to optimize your processes, for example, to make your process more efficient. So that will definitely that is definitely going to happen over the next few years, in my opinion. Okay, next.
And next question is, Peter, what is your experience with penetration testing OT? Is it a useful security activity?
Yes, that's a very good question, actually, because when you think about penetration testing, especially when you look at it from an IT perspective, and you paint that picture to the OT domain, you can already see PLCs falling over, rebooting, and things like that. But that does not really have to be the case, because penetration testing does not per se mean that you need to scan your PLCs or things like that. Penetration testing can also be walking up to the plant floor, walking up to a machine and see if there is such an electrical switch cabinet somewhere, and see if you can open it, and see if you can connect the serial port of your laptop to the serial port of a PLC. That also counts for penetration testing. Or you can find if there are open Wi-Fi networks that are connected to the industrial domain. So I think that penetration testing can be a very, very good add-on to the security of the industrial network. To be honest, I haven't seen any organizations in the Netherlands, at least, doing it. But I know from our colleagues, for example, in France, and with Orange Cyberdefense, that they do pen testing for their customers and for organizations. And I think it's going to be very useful, because then at least you know where your vulnerabilities are. Yes. Okay, next question.
Yeah, thanks. I see one more. Are there more sophisticated solutions for traffic analysis? Can you tell us more about network sensors?
Yeah, so that's basically what I just meant when I said Wireshark is great, but it's still a freeware tool, and it's not going to you cannot really compare it with commercial available solutions, because it does need a lot of manual work and even maintenance. There are also commercially available sensors that you can put in the network, and these are also intrusion detection systems, right? So one of the things that comes with an IDS is that it is never fire and forget. You will also have work on it, but there is a lot of automation in the commercial available solutions. For example, you deploy it, it will sniff the network traffic, and it will, for example, automatically build an inventory of devices, not just IP addresses, but actual devices, telling you that it's a PLC, telling you its brand is Siemens, telling you which software version it runs on, and it will show you which HMIs there are, what software it's running, which patch levels, and things like that. So the commercial available solutions are much more sophisticated in that sense and require less manual work. Having that said, because these devices are quite smart or intelligent, they will also notify you of anomalies in your network. And that's where the manual work comes in, because it will tell you which anomalies there are that you previously didn't even know of. But now when you deploy an IDS, you will start seeing these anomalies. And then obviously, you know, that means that you will have to take some action. So from that sense, you will need to do work on it as well. But yeah, definitely it is worth looking into if you're really serious about increasing the level of cybersecurity of your industrial network with as less as manual effort as possible. It is definitely worth looking into a solution that is commercially available, especially I would say because these kind of solutions really scale as well, where Wireshark is nice for looking at one control system, for example, but it doesn't really scale. And a commercial solution, you know, is actually built for that, so it scales much better. So yeah, very much worth looking into.
Okay, great.
Next one?
Yeah, we have a few more, but maybe some can also be taken offline. But one more interesting is, what is your opinion on OT-specific firewalls that can actively monitor and block based on contents of OT protocol packets, as we regularly find them badly configured at customer sites?
Okay, so what we see happening now is that all vendors, all firewall vendors, all security vendors, they have some proposition for OT. So, okay, so let's keep it to the firewall vendors. The most firewall vendors that we work with nowadays also can detect and see industrial protocols, and they can do the packet inspection on it, and that's a good thing, because these kind of firewalls are usually placed, or quite often placed, between the IT and the OT domain. And although you won't be able to see all traffic in the OT domain, at least you will see traffic crossing the boundary. So now that these firewalls can actually see and understand these industrial protocols, it will definitely increase the cybersecurity level. So that's a good thing. So then there's the other part. So what if we can see these protocols and we see something go wrong? Can we automatically adjust something or implement a rule or things like that? And the answer is yes, of course you can. And this is just like an intrusion prevention system. It sees an intrusion and it can take, well, some form of action. The question is that something that you want or that you dare to do in an industrial network? Because what if it's a false positive? And what if you stop the operational process, for example, or even worse, things go really wrong? So although we do have the technical capabilities, I don't think that many process operators or any operational people who are responsible for the availability of the operational process are really happy if you say that you're going to automatically block any traffic. Even in the IT domain, where cybersecurity is on a much higher level already, organizations are reluctant to do so. So I don't see organizations do this in the industrial network for any time soon.
Right.
Anything else?
Yeah, maybe the last one to close off with. A good question is artificial intelligence a threat or an opportunity for plant security?
So that's a good one, because Industry 4.0 is really about this. Industry 4.0 promises to change the factories that we know now, to change that into smart factories that are responsible for their own internal procedures and solve problems by themselves. So then you won't have an automated factory, but you will have an autonomous factory. You know, you can maybe compare it with autonomous cars. So is it a threat? Well, I'm not sure, to be honest. At this point in time, I think it is, because we see everybody doing things with artificial intelligence. But if you look for it, for example, movies on YouTube, where they really trying to teach a system something or let it teach itself something, you get very, very unexpected outcomes. And yes, the results are perhaps what you want, but the way of getting there is very strange every now and then. So at this point in time, I wouldn't trust artificial intelligence with my factory without proper monitoring. But will we get there in the end? Yes, most likely we will. But it will take a few years, I think.
Okay, thanks. Yeah, there's a few more questions, but I see also somebody who's already offline, so maybe we can take the questions offline as well. Thank you.
Yeah, sure. Okay. So yes, as was said in the beginning, this session is recorded, and you will receive this recording or a link to this recording for a later review. But also my email address is on the screen here. So if you need any support, please don't hesitate to contact me. I will for sure respond to the additional questions that are out there. And then for now, thank you very much for watching and listening. And have a great day. And we're closing this webinar. Bye-bye.